For the second part of this video, it's asking us to find the intercept form and then the standard form of each of these two graphs. Now, since we're doing the intercept form, let's just right away go and say what the intercept form is for our red graph on the left, and we'll go through that, and then I'm going to ask you to do the blue graph on the right. Firstly, for A of this first graph, the x-intercepts are identified as -7, 0 and -1, 0. It means, mathematically speaking, we would say our x integer is either -7 or x is equal to -1. Now, based on that, we can go and say that our equation is y is equal to a, because we don't know what our stretch is, and then we write x, oh wait a second, instead of having x is equal to 7, remember we're still using that zero rule, that opposite rule, to create this. So we end up with x plus 7, and then x, instead of -1, we end up with +1, because we're using our opposite world rule to generate it. Now that I've got my general intercept form, we have this beautiful thing down here. We have this beautiful highlighted thing here. That point is -4, -9. Let's sub -4, -9, -4, -9 into, let's call that equation 1. And we're going to get something like this. -9 is equal to little a times -4 plus 7, and then -4 plus 1. Now, we end up with -9 is equal to a times, well, -4 plus 7 is 3. -4 plus 1 is going to be -3. When we simplify the right side of our equation, we end up with a times -9 and -9. Now, this is where some of you guys forget. If I have a times -9, what you do is you just make it as -9a. Now, solve for a, you end up with a equaling 1. Because if you think about it, a is equal to -9 over -9, which turns into 1 in that case. So now that I have my a value, you're going to go and state your intercept form. This, and we're just going to substitute what we just got for our a value into our equation. I'm just going to put a 1 there. 1, and then we have x, well, plus 7 as before. Okay, and then we have x plus 1. And now, remember, that is a. So B is asking for the vertex form of our parabola. Oh, the standard form of our parabola. So when we do the standard form, all we have to do is expand this equation. So you start with y is equal to x plus 7, x plus 1. When you expand, you're going to get x squared plus 1x plus 7x plus 7. And we end up with y is equal to x squared plus 8x plus 7 as our standard form. Now what I'd like you to do is do the same for the equation that you see here to our right. So our new blue graph to the right has 2 points. Let's all say let's all agree that our x-intercepts are, well, I got a 4, 0 here, and I have -2, 0 here. Do your calculations and I'll tell you what your solution should be. Now, there's 2 ways to do this problem. If you recall, I taught you about the step method a while back. Now, the step method says that for regular y equals x squared, the steps are going to be 1, 3, and 5. Now, if I had the step value for our alternate equation, say minus 2x squared, our numbers would be -2, -6, and -10. And if I look at this problem here, we could go over 1 and down 2. So guess what our steps are? The steps are these things here. Some of you guys like doing geometric solutions, but they don't always work. So if I was looking at this, I would follow the same patterns as I did before, and I would find out that my a value should be -2 in this case. So I'm thinking the a value is going to be -2. So let's just verify that. Now, it only works sometimes, so don't use that all the time. Bad things happen. Take care. Here we go. Let's begin. I'll show the solution, you tell, and we'll just verify. So you'll notice that now we have our x integers, our x-intercepts to be -2 and +4. Now when we construct our intercept form of this quadratic, we're going to have x + 2 and x - 4, the exact opposite of what you see for each number here. Then you'll notice we have our beautiful point here. Our beautiful point, 0, 16, being suggested as the point that we use because it is the only fixed point that we can see that we were given. You use that equation in your solution. So substitute 0, 16 into your equation and solve for a. So now you're going to get 16 is equal to a times, well, 0 + 2 is just 2, and 0 - 4 is going to be -4 when you substitute that in. So now we're going to simplify, and we end up with 16 is equal to a times, well, -2 times -4 is going to be -8. So that simplifies to -8a is 16. Bringing a down, we end up with a is 16 over -8, which means a is -2, as we suspected. Now, I would tell you that you can use this as a hint. You use the step method that I identified a while back by looking at the graph and analyzing it. You can use that as a hint to give you an idea if you're on the right track for your a value. And then you go and do the x-ints, calculate just like this one, solve for your a, then state your intercept form. So we end up having -2 bracket x + 2 bracket x - 4. And now we're going to take that same equation and we're going to expand it using the concepts we learned in the previous chapter, i.e. factoring and expanding. So now we take our equation, y is equal to, well, -2. I usually leave that and I expand my quadratic. So I get x times x gives me x squared. And now x times 4 gives me negative 4x. And then 2 times x gives me plus 2x. And then 2 times negative 4 gives me minus 8. And then you end up with negative 2x squared minus 2x minus 8. And when we expand, our final standard form is take the 2 and distribute into every single term in this bracket to get the following. So we find that our standard form for this equation is negative 2 x squared plus 4x plus 16. And there you go. There you have it. So now let's move on to the final topic of today's lesson.